The transistor is ubiquitous in computer chips. In 2010, a single computer chip had over 800 million of them, and over 1 quintillion, or 10 to the, it should be 10 to the 18. Yeah, 10 to the 18 transistors are shipped each year. This was back in 2010. So what a transistor is, it can have two operations. I'm going to first talk about its digital operation. You can think of a transistor as a simple switch. So right now, if I want to turn on the light in my room, I can go over to the light switch, I can flip the toggle button, and it'll turn on the light switch. What if I want to turn on the light switch and turn on the lights in my room, but rather than doing a mechanical motion to turn it, I want to apply a voltage and have the voltage control my switch. So a transistor does exactly that. If I apply a voltage to the transistor, it can turn on and off other parts of the circuit. So the transistor is a three-terminal device, and the way that it works is that I apply a voltage from the base to the emitter. So if I have a voltage from the base to the emitter, then that allows current to flow from what's known as the collector to the emitter. So without this voltage, if I don't apply a signal to the base, then no current will flow from the collector to the emitter. So this base is acting as a switch. I apply a voltage, it allows current to flow, and therefore my light will turn on. I turn off the voltage going to the base, and current does not flow. Now, you'll ask yourself, well, why can't I just apply the voltage directly to the light switch or directly to the light and plug in and off the voltage? The answer is that I can control this high voltage. So let's say this is a 110 volt light bulb. I can turn on and off this 110 volt light bulb with just a 5-volt switch. In fact, I can probably do it with something like a single AA battery. Just that very small amount of voltage is necessary to turn on the transistor and allow a lot of current to flow. So this transistor can act in the form of an amplifier. By applying a very small voltage, I can control a large current. So that's the digital operation. There's also analog operation, which is I don't show here. I can flow a small amount of current from the base to the emitter, and that can amplify, and I can get a magnified version of current flowing from the collector to the emitter. So most transistors, I need a minimum of about 0.8 volts from the base to the emitter to turn it on. If I apply less voltage, then the transistor doesn't turn on. And an important graph is what is the current going from the collector to the emitter as a function of the current that's flowing into the base. So if I have, if I'm below this 0.8 volt threshold, then as I increase the current to the base, I get an amplification and I get significantly more current going through the collector, from the collector to the emitter. So I have this part of the graph. But then as soon as I turn it on, the current that flows from the collector to the emitter starts to flatten out. And so I get the maximum amount of current, and I get a constant current as long as I've turned on the switch. If I'm at a voltage, or if I'm at a current through the, and I'm mixing up voltage and current. So if this should be VB rather than IB. If the voltage is less than 0.8 and I have a so the circuit that I need to have a resistor in here. And if I apply greater than 0.8 volts, then I have this saturated part. And if I have less than 0.8 volts, I have this amplification part. So the transistor can be used to amplify the current that's flowing in a circuit. For example, like when I have my loudspeakers, I have a very small current that's existing in my microphone. That current then drives a transistor, which amplifies the electrical signal, which can then drive my speakers, and you can hear me loud and clearly. So the transistor has many functions. We're going to talk specifically about its digital operation as a switch. We're going to talk about if I apply a 5-volt signal, I can turn on a current. So what we're going to do in the remainder of the time is we're going to build this mini circuit, which what we're going to be able to do is by applying a signal to the base of the transistor, I can control the flow of current through this LED configuration. Time permitting, which I don't think we will have, there's this other more complicated circuit that has this flashing LED. So it's using capacitors to charge and discharge, And when one capacitor charges, it drives the base, and that turns on the LED. And then that starts to discharge the capacitor, and then the other capacitor starts to charge, and then that drives the second LED. So this circuit will flash the different LEDs because you're charging and discharging capacitors, which are driving a transistor. Let me pause and ask, are there questions so far before I get into talking about the project that we're going to build?
If you have like more volts than 0.8, would that like does it just like waste volts like
Yeah. So if I have the transistor and I try to apply more than 0.8, what happens is that the transistor will still turn on. So if I applied a 5-volt signal, the transistor will turn on. If I had a perfect voltage source that gave me 0 resistance, I would actually burn out the transistor because the transistor can only take 0.8 volts. In a practical system, there's going to be a small amount of resistance, and that's going to limit the current that's flowing into the base. And so the actual voltage drop from the base to the emitter will be 0.8, and I'll lose the rest of the 5 volts somewhere in the line. So in the circuit that we're going to build, we're going to put in specifically this resistor. So I drive with a 3-volt signal, but the voltage from the base to the emitter is only going to be 0.8, which means that the voltage at this spot of the resistor is going to be 1.2 volts. And so the current that flows through this resistor will be the 3 minus 1.2, so 1.8 volts across the resistor, divided by a kilo ohm. So I'll get 1.8 milliamps of current flowing into the base and to the emitter. So very good question. So in the case that I have a voltage signal, like if instead of this being 3 volts, if this were 1.5 volts, then what would happen is this point, this point would still be at 0.8 volts. And so I would drop 0.7 volts across the 1 kilo ohm, and I'd get 0.7 milliamps of current flowing into the base. But that's still enough because the voltage I'm applying is still greater than 0.8. It's still enough to turn on the transistor.
if you like put less voltage, would it if there was less voltage, would you have to use like a weaker resistor?
Yeah, so if I change this and I set this, instead of being 3, if I set this to 0.5, there's no way I can turn the transistor on. With 0.5 volts, it's not enough to turn on the transistor. In the same way, like you had the LED, if you don't apply enough voltage, it just doesn't flow enough current to do anything. So if I apply 0.5 volts, even if I got rid of this resistor, so I made it a 0 ohm resistor, there's not enough of a voltage drop across the base emitter to turn on the collector. So there would be no current flowing if I applied 0.5 volts. So that's a very good question.